In section 4.4, we are going to talk about proving some more theorems, and this first box has some more reasons that we are going to use to prove our statements in our proofs. So the list of 4 here, we have the definition of a right angle. We know all right angles are 90 degrees. So if we are trying to say that a right angle is 90 degrees, that's the reason we can use our definition of a right angle. Same thing for our straight angle. We know that is 180 degrees. We know a linear pair is also 180 degrees and they are adjacent. And then the definition of perpendicular lines means that we have 2 lines when these angles are all 90 degrees. 90 degrees each. Okay, so once you have proven a theorem, it can be used in any later proof as a reason, so you don't have to prove all these theorems all the time. So we're going to start with our midpoint theorem. So once we prove the midpoint theorem, we can just use the midpoint theorem in our next proofs. So I know that these slides are a little hard to see on the screen, but you have them written right in front of you where you can see a little better what it's saying. I'm going to write my statements and reasons on this side. Okay, so my midpoint theorem, the first part says if M is the midpoint of AB, then AM is congruent to MB. That is what we are trying to prove. This part is our proof. Then this part right here, M is the midpoint. It's our hypothesis. And this proof is our conclusion. And our hypothesis is our given information here. So if we are given that M is the midpoint of AB, that's going to be my first statement. And the reason I can say that is because it is given. Now, the next thing I want to do, I'm trying to prove that AM is congruent to MB. Well, if I know that M is the midpoint of AB, then I know that AM is congruent to MB because it is a definition of midpoint. So using these definitions are very helpful because this makes this proof very short. It's the definition of midpoint, so we know AM is congruent to MB. Okay, let's look at the next one. If 2 angles form a linear pair, then they are supplementary angles. And it has a diagram over on the side here. So we are given 2 angles form a linear pair. It's our hypothesis, which is our given. And we are trying to conclude they are supplementary. And this is what we are trying to prove. Okay, so let's start with statements and reasons. In our diagram, we have angle 1 and angle 2 are a linear pair. given. Our next piece of this, if we know angle 1 and angle 2 are a linear pair, we also know that angle GMR is a straight angle. That is our definition of linear pair. They are adjacent on a straight line. That's what the GMR as a straight angle means. Definition of linear pair. Our next step, if we know angle GMR is a straight angle, then we know that the measure of angle GMR is 180 degrees. That's our definition of a straight angle. Now we're trying to prove that angle 1 and angle 2 are supplementary, so we want to get angle 1 and angle 2 back into this, into these statements. So if I say that the measure of angle GMR is equal to measure angle 1 plus measure of angle 2, I can say that because it is our angle addition postulate. If two angles make up a big angle, then the big angle is the sum of the two smaller angles. That's our angle addition postulate. Now that I have angle 1 and angle 2 back into my equation, I know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees because GMR equaled 180 degrees. And I can say that because I substituted in angle 1 and angle 2 for GMR. Finally, if I know angle 1 plus angle 2 equals 180, I can get to my conclusion. Angle 1 and angle 2 are supplementary. Because that is our definition of supplementary, two angles that add up to 180. Okay, so that is how we prove that those two angles are supplementary. Our next example says angles complementary to the same angle or to congruent angles are congruent. So if we look at our diagram here, this is saying that if angle 1 is complementary to angle 2 and angle 2 is complementary to angle 3, this is our if statement. If that is true, then angle 1 and angle 3 must be congruent. So this if statement is what we're going to start with. That's our given. We have angle 1 and angle 2 are complementary. and angle 2 and angle 3 are complementary. That is our given. Oops. A. Well, if we know angle 1 and angle 2 are complementary, we could add those up. Angle 1 plus angle 2 would be 90 degrees, because that is our definition of complementary. Same thing with angle 2 plus angle 3. Just going to write it on that line because it's the same reason. Both those statements are true because it's the definition of a complementary angle. Now, if I know angle 1 plus angle 2 is 90 and angle 2 plus angle 3 is 90, I could say angle 1 plus angle 2 equals angle 2 plus angle 3 using substitution. Since I know angle 2 plus angle 3 equals 90, I'm just going to take this 90 right here and replace it with angle 2 plus angle 3. Now if I have this equation on line C, if I subtracted angle 2 from both sides, that would leave me with angle 1 is equal to angle 3. That is our subtraction property. And finally, I'm trying to prove angle 1 is congruent to angle 3. And if those measures are equal, then I know angle 1 is equal to angle 3. Definition of congruent. Okay, let's look at the vertical angles theorem next. If we are given that two angles are vertical angles, so let's say angle 1 and angle 3 are vertical. So we have if angle 1, angle 3 are vertical, then they are congruent. Okay, so I'm going to start with my hypothesis up at the top. If we have angle 1 and angle 3 are vertical, if I look at my pairs here, angle 1 and angle 2, in my diagram, those are a linear pair. The same with angles 2 and angle 3. They are on a straight line. And I'm just going to write, and so are angle 2 and angle 3. This is our definition of a linear pair. If I know those two things are true, I can then write angle 1, my measure of angle 1 plus the measure of angle 2 is 180. And the measure of angle 2 plus the measure of angle 3 is 180. And we proved this from our supplement theorem. I have both of those equations are equal to 180, I can then substitute my second equation into that 180 in my first. So I get the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Substitution. Just like I did in the last example, I have a measure of angle 2 on both sides, so if I subtract that from both sides, I get the measure of angle 1 is equal to the measure of angle 3, which is a subtraction property. And then finally, I'm very close. I'm just trying to get angle 1 congruent to angle 3. And if those angles are equal, then I know angle 1 is congruent to angle 3 because the definition of congruence. Okay, and we are going to skip that last example. So that is all the notes for 4.4.